Hello there, everyone. Welcome back to what I believe is our fifth SAT preparatory class. Let's not waste any time and let's get started. I apologize if the audio quality is a little bit not so good. I am in a different, I'm away from home right now, so I can't use my typical nerdy headphones. If I remember correctly, the last time we left off, we were talking about unique types of quadratics, or rather, we were not talking about them. We were going to start talking about them next class, and next class has come. Okay, so when it comes to making quadratic equations, there are three main ways to write them. We have the standard way, ax squared plus bx plus c, which is pretty nice. And however, the problem with the standard form is that it doesn't really give you that much useful information other than the y-intercept, maybe. That's pretty much all it tells you. The intercept form is written as this: x minus something times the quantity of x minus something times the quantity of x minus something. And when you write a quadratic in this form, you get two important pieces of information. The format represents the x-intercepts of the quadratic. I'll explain down below. And then we have vertex form down here, which tells you what the vertex of the quadratic equation is. What do I mean by vertex? When you have a parabola or a quadratic equation, the vertex is the point that's either all the way at the top if the parabola is open facing downwards, or the point that is all the way at the bottom if the parabola is facing upwards. Now, I want you guys to look in this box over here. It might surprise you to learn this, but all of these three equations you see here, they are all the exact same equation. They are just written in three different ways: standard, intercept, and vertex form. And what's cool is that you can use these forms to figure out the general shape of a quadratic. For example, if we had a coordinate plane, let's just say here, if we look at x-intercept form, we see that we have x minus 3 and x minus 1. In order to find the x-intercepts, all you have to do is set x minus 3 equal to 0 and x minus 1 equal to 0. So that means x is going to be equal to 1 and 3. And that means that the x-intercepts are going to be here, 1 and 3 on the x-axis. And then for the vertex form, the way you find the vertex is you take this term that's inside the parentheses, which is x minus 2 in this case, you set that equal to 0, and then we get x is equal to 2, and then whatever this number is over here, that is the y value. So yeah, y is going to be equal to -1, so the vertex is going to be 2, -1. So that means the vertex would be somewhere down here. And then standard form over here is not terribly useful, but it gives a little bit of guidance because we know that the y-intercept is 3 over here. So 1, 2, 3. The y-intercept would be somewhere around here. You can draw a very rough shape of what the parabola is supposed to look like from all this information. Are there any questions? Nope. Okay, let's move on. So, representing quadratic equations or representing intercepts. Okay, a graph of which of the following functions in the xy plane has x-intercepts at -4 and 5. Okay, so we have to use the intercept form knowledge that we have. So y is equal to x minus q times x minus p. Now remember, what intercept form tells you, if you take these inner terms and you set them equal to 0, then whatever x is equal to is your intercept on the x-axis. Okay, so if we have an x-intercept at -4, and 5, then we can sort of reverse engineer that, where we know that the equation has to be y is equal to x plus 4 and x minus 5. Now we say x plus 4 because it's a negative 4 up here. So if we set x plus 4 is equal to 0, that means x would be equal to negative 4. If we did not make that plus sign and we made that a minus sign instead, then we would get x is equal to 4, which is incorrect. And then obviously x minus 5 is equal to 0, x is going to be equal to 5. So the correct answer is going to be option A, right up here. Are there any questions on that? All right, let's move on. Okay, interpreting quadratic graphs. This one is a little bit of a tough challenge. It's tough because it's difficult to understand. Okay, the function f of x is equal to x to the power 4 minus 2.4 x squared is graphed on the xy plane. Okay. Okay, when they say y is equal to f of x, that's just them just trying to put a bunch of gibberish in there. By saying y is equal to f of x, they just make the equation y is equal to x to the power 4 minus 2.4 x squared. Basically, f of x is the same thing as y practically when you're talking about coordinate planes and graphing. Okay, if k is a constant, don't let these words fool you. Just if you simplify it, what they're saying is if we have a number k where the equation f of x is equal to k has 4 solutions, which of the following could be the value of k? Okay, if you have an equation like f of x, which is basically y, like y is equal to any constant, what's that going to look like? Let's say y is equal to 5 on this graph. Y is equal to 5 would look like a straight horizontal line. Okay, so they're saying if k is a constant where the equation f of k has 4 solutions, which of the following is the value of k? So what do they mean by 4 solutions? In this case, they're asking us to make a system, and what's basically happening is that in order to have a solution, if you have a 2 equations and you need to find the solution for both of these equations, you have to find the points where they intersect, right? Like if you had 2 lines, one going this way, one going that way, this is where the solution would be, right? So they're saying that if we have to find a number k where if we draw the horizontal line anywhere on here, we have 4 solutions. So where are we going to have 4 solutions? Well, we're definitely not going to have 4 solutions up here because that is 1 intercept and 2 intercepts. And we're not going to have it down here, that's only 2 intercepts. But if we had it, say, in this range, okay, it's a bit hard to see. But if we had a solution somewhere over here, then we would hit 1, 2, 3, 4 solutions. So let's backtrack a little bit and say, okay, if k is equal to any numbers in between this value, so a little bit above -2 and underneath 0, then that means we're going to have 4 solutions. So which of the following answers best make sense? Well, it can't be A because 1 is above 0. It can't be B because B is equal to 0. You see, B is equal, if you choose 0, you're going to have 3 solutions because you're going to have 1 solution here, 1 solution here, and there's going to be a tangent where it just brushes the x-axis right up there. And yeah, that's not what we want, if you think. An option like -2, which is D, would not be correct either because -2 is clearly too low. So the correct answer is going to be C. Are there any questions about this? All right, nope, let's move on. Okay, interpreting complex equations. This is a bit of a logic question. I'm going to give you guys 2 minutes to solve these on your own starting now. They shouldn't be too complicated. All right then, everybody, 2 minutes are up. So let's come back and take a look at these two questions. So like I said, these are interpretation questions. They give you information. You have to figure out what exactly it means. Okay, first question. For a certain reservoir, the function f gives the water level f of n to the nearest whole percent of capacity on the nth day of 2016. So the nth day, n is what is going into the function. So n is sort of like the x variable. And then f of n is going to be the y variable, if that makes sense. So that's how I perceive it. Which of the following is the best interpretation of f of 37 is equal to 70? Okay, so if we know that this, okay, let me change to vanishing pen. If we know that this n over here is equal to an nth day of 2016, then that means f of 37 over here, that means, well, the 37th day of 2016. So immediately, my mind is going to jump to C. On the 37th day of 2016, the water level of the reservoir was at 70% capacity. And recognize that they say the function f gives the water level to the nearest whole percent of capacity. So f of n is equal to percent capacity. And that is further confirmed, with them saying 70% capacity. That is consistent with the information. All right, the next question, definitely a little bit trickier, but it should be easy to explain. Okay, physics question. If an object of mass m is moving at speed v, the kinetic energy is given by this thing over here. If the mass of the object is halved and its speed is doubled, how does the kinetic energy change? Okay, so you can actually represent this in an interesting way. Basically, what you can do is you can say, okay, if we have a new kinetic energy where mass is halved, then you simply replace the m with m over 2. Yeah, you can do that in order to represent how something is getting halved. You see, at the end of the day, when we're solving an equation like this, we're not going to know the exact amounts of each equation. We're not going to say, oh, the first equation, you'll get a value of 50, and the second equation get a value of like 30. We're not going to know that exactly, but we're going to get a ratio, and that ratio is going to tell us how much the value will be different by. So for now, let's just replace the mass with mass over 2 to represent that the mass is getting halved, m over 2. And then the velocity, let's say the velocity they say is doubled, speed is doubled. So that means velocity changes into 2v, velocity times 2. So then remember, however, v has an exponent. So we have to make sure that the 2v is under an exponent as well. What does this all come out to? 4v squared over, so 4v squared times m over 4, which equals v squared times m. So for the first equation, kinetic energy is equal to half of mv squared. And then the second equation, once we modified it, kinetic energy is equal to mv squared, if we just rearrange the variables a little bit. So that means we eliminated the half. So what does that mean? That means that if we do what they tell us and we half the mass of the object and we double the speed, then we doubled the kinetic energy. So the correct option is going to be C. Are there any questions? Yukuda, you have a question?
So we squared it, but then we had the v squared after as well. So why did we keep the v squared even though we already squared the variable?
We did keep the v squared.
I was wondering why we kept in the KE at the bottom, it
Yeah,
has 2v squared, and then
yeah,
after at the end we have v squared times m. Why do
yes,
we
yes.
have it even after we have squared it? That's what.
Oh, because basically, we keep it because, at the very end, we combined all the variables together. So what we are left with is v squared times m. It's not like we kept it or eliminated it or anything. V squared was always there. We just, I mean, if you just look at the math and just do it sequentially, then you should be able to see that v squared naturally comes to fruition.
Why did we square the 2v?
We squared the 2v because the original equation, half mv squared, we're trying to represent how changing the velocity to be doubled affects the kinetic energy. So it's like we're substituting basically. V is equal to 2v. Like if you've ever taken computer science, you know how you can change variables, like, this is equal to something new, and it changes the value of the it changes the net value of whatever equation you used it in. So it gives you like a different representation.
Okay, thank you.
No worries. Okay, so here we have a more interpretation. I'm gonna let you guys take a crack at this for 2 minutes starting now. All right then, everybody, 2 minutes are up, so let's come back and check out these questions. All right. Ignore everything at the top. You don't need to read that. Okay, basically they're asking which of the following correctly expresses M2 in terms of M1, R1, and R2. When they mean express, what they mean is simply take this variable and isolate it. Isolation means taking everything and moving it to the other side, leaving M2 all alone. So first order of business, M2 is trapped in this sorry, M2 is trapped in the square root, right? So what we are going to do is we are going to square the entire equation. So we end up with R1 squared over R2 squared is equal to M2 over M1. And then simply we just multiply the whole thing by M1 to get rid of the M1 denominator. And we get M2 is equal to M1 times R1 squared over R2 squared. Now, which answer is correct? Well, it can't be C or D because they have the square roots on top of their M1s, and that's bad. Seems like the correct answer is going to be A. The minor distinction between A and B, they look very similar, but they're not the same, is that the R1 value is on top for A, and then the R2 value is on top for B. And we just established that the correct answer, R1, needs to be on top. Now, for the next question, this one definitely a little bit unique. It's using the vertex form that we discussed earlier. So basically the vertex form was, okay, I don't remember the exact formula, but it was something around like y is equal to, a times x minus h squared plus, b, let's just say it like that, okay? Where basically x minus h represents the x variable of the vertex, and then b represents the y value of the vertex. Now, a store manager estimates that if a video game is sold at a price of $P, the store will have a weekly revenue of R of P. Which of the following equivalent forms of RFP? So they say equivalent forms, which immediately tells us all of these equations are correct. All of these equations are the same thing. Which of the following equivalent forms of RP shows as constants or coefficients the maximum possible weekly revenue? Well, in order to fix that, seems like we got a couple people who are having some troubles with seeing the screen. Um, everything looks good on my end. If you're having trouble seeing the screen, then I recommend exiting the meeting and then re-entering. But yeah, as I was saying, so how do we find the maximum possible weekly revenue? Okay, well, if we have, a coordinate plane and R of P represents profit, then we have to find the highest value of R of P, right? And how do we find that? Well, here's a small trick. You see how the coefficient is negative over here, negative 4 P squared? Here's something. If A is negative, that means that the parabola is facing downwards, like this. If A is positive, so, that means the parabola is facing upwards. So that means if R of P is equal to negative 4P squared, that means the parabola is going to be facing in this shape. And what is the highest point of a parabola like that? Excuse me, it's going to be the vertex of that parabola. And we just established that vertex form over here gives us the vertex. So if we can write vertex form, we can get the vertex of the parabola, and we can figure out what the maximum possible weekly revenue is. Yeah, so keep that in mind. Vertex form, if you're in terms of practicality in real life, vertex form can help you find the extreme values, either the absolute lowest values or the absolute highest values. Okay? All right, yeah. So the correct answer, without much thought, is going to be D, because D is in perfect vertex form. We have the X variable here, and we have the Y variable here. All the other equations are not in vertex form and/or they are not written properly. A is literally just the same thing as the original equation. B just factors out -2 for no apparent reason. Same thing for C, it just uselessly factors out -4. So D is the best answer. Are there any questions? Gananeswar, you have a question?
Yeah, so basically when in the question it says as constants or coefficients. So in many questions they say this. Like, do we need to
Yeah.
consider or something?
Okay, so what they mean when they say as constants and coefficients, they are asking, look for a form of the equation where the numbers will directly tell you how to find something. And that is what is happening in this question. You see how we have P minus 25 and we have 2,500. So the 25 over here and the 2,500, they are both constants that help us figure out what the maximum possible weekly revenue is. So do you understand what they mean by that now? Okay, great. Sriyata, you have a question?
Yeah, so like just so I can visualize it, how'd
Yeah,
they get the 2,500 again? Because I know like that is the vertex,
yeah,
like 25 and
yeah.
2,500, but like how did they get that from like -4p squared plus 200p?
Okay, so you really don't have to worry about that at all.
Okay,
There is like a lengthy-ish process for converting equations into vertex form, but all you need to know for this question is how to identify vertex form and how vertex form can be helpful.
okay.
All right, yeah. But not a bad question though. I don't believe there are going to be questions that require you to make your own vertex form. But if they do, they'll likely be, very, very easy and you'll be able to do it intuitively. Sahi, you have a question?
So can't you just use for the question she asked before, can't you
Yeah.
just use completing the square formula?
The completing the square, yes, actually, yeah, that completing the square formula is the main method what we use to create vertex form. Yeah, that was slightly jumping the gun. We are actually about to get to completing the square a little bit later on, so it's a very good thing that you brought that up early on. Yeah, good catch there. But yeah, no, don't worry. We will eventually get around to, making equations like that. Okay, now we are going to get into a little bit of geometry. Geometry is a surprisingly prevalent portion on the SAT, so you definitely should know about all of it. All right. So geometric postulates you should know. Okay, what is a postulate? A postulate is basically just a rule that you need to know, that you need to keep in mind. They can be very, very important for figuring out certain logistics. Okay, imagine we have a scenario which I represented on screen here. When a line cuts through two parallel lines. So I want to give you guys a little bit of a legend terminology. Let's say you have two lines and they have an arrow mark on them like this, that I believe means, okay, wait, let me just look it up just to be sure, because I don't want to misinform you. Yeah, okay. So if you see if you see two lines that look parallel and they have these arrow markers in the middle of the line, that means that they are parallel, okay? Okay, and now imagine we have these two parallel lines and we have another line that's cutting right through it. So there's 4 rules you should be aware of. Alternate interior angles will be congruent. So what does that mean? Interior means within the parallel lines, and exterior means outside of the lines. So interior means inside, and then alternate means on opposite sides of the cutting line. So this line over here is what I like to call the cutting line. It's cutting across the parallel lines. And angles that are interior and on opposite sides of the cutting line are congruent. So let's take angles 3 and 6 over here. 3 and 6 are both inside of the parallel lines, and they are opposite on the crossing line. So that means they are congruent. And congruent means they have the same size. And you can represent congruency by drawing a curved mark around the interior of them. And in order to represent, someone in chat just gave a very, very useful bit of information. Thank you, Mohit. The cutting line is called the transversal. Thank you very much. But yeah, on opposite side of the transversal. Now another example of alternate interior angles would be 5 and 4. They are interior. They are on opposite sides of the transversal. That means they are congruent. And you see how I represented them differently? I represented them with a double line. That means that 4 and 5 are congruent. And if you had 3 and 5 and you've compared those, because they have one has 2 markings and the one has 1 marker, that's an obvious sign, aside from the fact that they don't look congruent, that they are not congruent. Now, however, there is a relationship between angles like this. Same side interior angles will be supplementary. Okay, so same side means that they're on the same side of the transversal, and interior means inside, right? So what are examples of same side interior angles? Well, for one, 3 and 5 would be considered same side interior angles. And being supplementary means that the values of 3 and 5 add up to 180. So, angle 5 plus angle 3 is equal to 180 degrees. So 3 would probably be equal to something somewhere around like 45 degrees, and then 5 would be somewhere equal to 135 degrees. So 135 plus 45 is equal to 180. Another example would be 4 and 6. They are same side interior angles. If you take angle 4 and 6 and add them up, they will be equal to 180 degrees. Oh, and then the last one, corresponding angles. So corresponding angles is something you kind of have to visualize. But corresponding angles basically means if you take 2 angles that are in the same quadrant, they are congruent to each other. Let me show you visually. If we take angles 3 and 7, and in this situation, we see angles 3 and 7 are sort of in the bottom left corner of the 4 angles created up top and up bottom. So these 4 angles, they occupy the same type of space, the bottom left. And because the 2 lines are parallel, that means angles 3 and 7 are both congruent. So angle 3 is equal to angle 7. And then, something similar, let's take angle 8. Angle 8 and then angle 4 are in the bottom right quadrant. So they are congruent to each other. And okay, that is the correspondence rule. That one definitely requires a decent amount of visualization, but it is pretty intuitive. And then the last one, which is also kind of intuitive, opposite angles are congruent. What does that mean? Basically, if you have 2 lines crossing each other, the angles that are literally opposite to each other, like on opposite sides, so like this angle over here and that angle over here, they are congruent. They are the same size. So in this case, angles 2 and 3 are congruent, angles 5 and 8 are congruent, so on and so on. So, and for further clarification, someone in chat said that these angles are specifically called vertical angles. Thank you. Oh, whoops. Okay. So we got a really, really complicated question here where basically we have to find, okay, in the figure above, line L is parallel to line M. Okay, so that should kind of be, giving us an idea that, okay, we're probably gonna have to use some angle postulate rules here. They say segment BD is perpendicular to line M. So what does perpendicular mean? Perpendicular, which is can be represented like this. Perpendicular means 90 degrees. So, a perfect right angle, sharp angle like that. What is the length of segment AC? Okay, so A all the way to C. So what I want you guys to do now is you don't have to exactly solve the equation, but I want you to figure out as much information about this scenario as possible. Try and find the lengths of lines DE, AE, EC, BC, and see if you can maybe get an idea of what the length of line AC is, because finding all those bits of information is crucial to solving this problem. I'll give you guys 3 minutes to do that starting now. All right, everybody. Now that I've given you a little bit of time to think on this question, let's actually try and tackle it. Okay. So, finding the length of segment AC. So first order of business, we should find the length of segment AE. What is that equal to? Well, the Pythagorean theorem, which is something that everyone should know, but in case you don't know, is basically where you have a triangle with side lengths A, B, C, where C is something called the hypotenuse. You can basically, if you know the values of two sides of a triangle, you can easily find the side length of the last unknown side. So in this case, we don't know what the C value is. We don't know what this value is over here, but we do know that the quote unquote A is equal to 12 and the quote unquote B is equal to 5. So we can do 12 squared plus 5 squared is equal to 169, which is equal to C squared. And then if we square root both sides, we get C is equal to 13. So this is equal to 13. Now, we have to find the length of EC. And yeah, finding the length of EC requires you see, there's no exact way to find EC, because we don't have the side length of BC easily. But here's something important. You see, there is this concept of similar triangles similar shapes, where you can have two shapes that have the exact same proportions, but are sized differently. You know, like these two triangles, same proportions, but have different sizes. An example would be, you know, if this triangle had the proportions of 10, 6, 5, and then the smaller triangle had the proportions of 5, 3, 2.5. They are basically the same triangle, but one of them is just scaled up to be bigger. Now, here is the thing. There are a couple of rules that you guys should know. One of them being that if you have a triangle that has the same angle, if you have two triangles and they all have the same angle values, so let's check first of all. No, let me first explain it. If you have two triangles that have the same angle values but different side lengths, that means that they are similar triangles. So that is very important to this question. So how do we know if these triangles are similar though? We have to figure out if they have the same angles. Well, for one, we can say that angle AED over here is equal to angle BEC because they're opposite angles. And then angles D and angles B, the question literally says that they are perpendicular. So that means that those angles are the same value. Now, the last two angles, angle A and angle C, we know that they are congruent to each other as well because they are alternate interior angles. So triangle ADE is similar to triangle BEC. Now, what this means is that we can use proportions to figure out the side lengths of EC. So how do we do that? Well, we know that if triangle EBC is similar to triangle ADE, which means, same triangle, just scaled differently, then we see the side length of EB, which is 1, it corresponds to the side length DE, which is 5. So if they're the same triangle, but scaled down, that means that triangle EBC is basically 5 times smaller. So whatever the corresponding value on triangle ADE is, you just divide it by 5, and that is going to be the side length for the corresponding side on triangle EBC. So in order to find EC, all we have to do is take 13, multiply it by 1 over 5, and that is equal to 2.6. So that means segment EC is equal to 2.6 in terms of side length. So now we have our side lengths AE and EC. So if we add 13 and 2.6, we get a side length of 15.6. Are there any questions with the process of how we got here? Okay, Aditi, you have a question?
Yeah, so we know that it's perpendicular, 90 degrees, all of that, but can we, if it's not stated in the problem that these two triangles are similar,
Yeah.
do we still, is there supposed to be anything in the problem that states that we should use the similar triangle rule?
If they do not state that the two triangles are similar, then yes, you do absolutely need to figure out by yourself that the triangles are similar to each other. You're not allowed to assume anything like that. Yeah, that's pretty much it. That was a good question. Katya, you have a question?
How do we know that we're going smaller by 5 times, or we're multiplying? Why are we multiplying by 1/5?
we're multiplying by 1/5 because we know that triangles ADE and EBC are proportional to each other. And we see the side lengths of, let me change to a spotlight. The side lengths of DE and EB are given to us, that is 1 and 5. So that basically sort of tells us, okay, triangle ADE is 5 times bigger than triangle EBC because the corresponding side lengths for ADE and EBC, basically ADE is 5 times bigger for all sides because they gave us that information.
Okay, so if DE is like, for example, 6 and like
Yeah.
AE is like 2, it'd be 3 times bigger.
I think you mean if DE was 6 and then EB was 2, then yes, a triangle ADE would be considered 3 times bigger. Yes.
Okay, thank you.
All right, no problem. That was a good question. Are there any more questions? Nope. Okay, let's move on. An isosceles triangle. In the figure above, a regular polygon with 9 sides has been divided into 9 congruent isosceles triangles by line segments drawn from the center of the polygon to its vertices. What is the value of x? Okay, approaching this problem can be a little bit tough. Katya, do you still have a question?
Oh no, I just sorry.
No worries. Okay. So finding the value of x. First order of business, what is an isosceles triangle? An isosceles triangle is basically a triangle that has 2 side lengths that are the same and 1 side length that is not the same. As a consequence, it has 2 angles that are the same size and 1 angle that is not the same size. Usually the angle at the very tippy top. So in this case, we have to find the value of x. Now, how do we find the value of x? I'll tell you, we have to find the value of this angle over here because these 2 angles are equal to each other. So if we can find the value of the top angle, then we can find the value of the 2 bottom angles, because this is also another thing you guys should know. All the angles in a triangle add up to 180 degrees. And I believe that for every extra side that gets added to that, you add, okay, I'm not exactly sure. There's a formula out there somewhere. I'll get back to you guys on that later, but I believe you add 90 degrees or you add 80 degrees. We'll discuss that later. Okay, but for now, I want you guys to envision this. This isosceles, these 9 isosceles triangles, if you had like a circle in the middle, let's say a circle like this, you would say that the circle, it goes a full 360 degrees, right? And then basically we have 9 angles all in the center over there. So all those 9 angles, if you add them up together in the center of this structure, they add up to 360 degrees. If all those angles are equal to each other, then we can basically do 360 divided by 9, have that equal to 40, and just like that, we found the angle measure of the central angles. So this angle over here is equal to 40. Let me reiterate, every single angle is also equal to 40. And the way we found this was that if all the angles come to the same point, it's like they're, fully going in 360 degrees. So 360 degrees divided by 9 angles that are all together is 40. So that is 40 degrees. So angle A, let's say that's just equal to 40 degrees. And then angle B is equal to angle C. Angle B is going to be this angle down here, and then it's going to be that angle down there. They are both congruent to each other. So, you can basically just say, okay, 2 angles are equal to, sorry, maybe I'm getting a little bit ahead of myself, but basically angle A, which is equal to 40. So plus angle B plus angle C, that's all equal to 180 degrees, right? So if angle A is equal to 40, we subtract 40 from both sides, we get 140 over here. And if B is equal to C, then let's say, we have two angle B's. Two angle B's are equal to 140. Angle B is equal to 70 degrees. So in this case, the value of X would be 70. Are there any questions? Nope. Okay, let's move on. Okay, special triangles. This is something that you guys are actually going to have to memorize. So in the world of geometry, there are two types of special triangles. We call them special triangles because they are triangles that have recognizable patterns, and that those patterns allow us to find the angle measures super duper easily. Let's get back to talking about special triangles. So the first special triangle is a 45, 45, 90 triangle. It's pretty easy to understand what these numbers mean. Basically, they represent the degree measures of each angle. So, 45, 45, 90. And a 45, 45, 90 triangle has a side length ratio of 1, 1, root 2. So basically what that means is if you know the side lengths of, say, this side over here, basically these two sides are congruent to each other, and then the hypotenuse, or this long side over here, is equal to that side length times root 2. Now, just so you can visualize it better, root 2 is, approximately equal to 1.4. So you could say that this hypotenuse over here is around 40% larger than the adjacent sides. Okay, so just to give you an example, if we had a triangle that was 45, 45, 90, and we saw that the side length on one of the adjacent sides was 3, then I would know based on the ratio that the side length for the other adjacent side would be 3 because those two sides are congruent. And then the side length for the hypotenuse would be 3 times root 2. Or you could, in decimal form, it would be something larger than 3, okay? For the next triangle type, we have the 30, 60, 90 triangle, a little bit more finicky to work with. And this triangle has the ratio of 1, root 3, and 2. For reference, root 3 is around 1.7, I believe. So the smallest side, which corresponds to 1 in this case, if you're wondering why certain sides are small and why certain sides are big, it actually depends on what angle they correspond to. What I mean by that is what angle is open to the side. In this case, the 30-degree angle is facing this small side over here. And then the 60-degree angle is facing this root 3 side over here. And then the 90-degree angle is facing this 2 side over here. And, if you think about it, if you have a small angle, then the side is going to be small, right? Going forward like that. But then if you have a large angle, then the side is going to be much bigger, right? So, just some basics like that, basic thinking that kind of tries to explain why certain sides are smaller and bigger in triangles. If you ever see a 30, 60, 90 triangle, you should keep this ratio of 1, root 3, and 2 in mind. Okay, so let's actually try and put this to use. So for these questions, I'm going to write down the ratios down below. You don't have to use the decimal form. You can just use the roots. You don't have to go further than that. And keep in mind that I'm going to give you information that doesn't start out at the lowest value. Sometimes I might give you information where I tell you the side length of the hypotenuse side over here. So you have to reverse engineer from that and do a little bit of division maybe. Okay, I'm gonna give you guys 2 minutes to practice this starting now. All right then, everybody. 2 minutes are up, so let's come back and check out these questions. All right, so the first triangle, we have to find the side length A. That's pretty simple. We know that this, which corresponds to 1, is equal to 3, and then the hypotenuse corresponds to root 2. All we have to do is take 3 and multiply it by root 2. So A is equal to 3 root 2. Now, X, on the other hand, a little bit more challenging. It corresponds to the 30 side, excuse me, which is, equivalent to 1. And then the 60-degree side corresponds to root 3. So think of it like this. If X is equal to 1, then X times root 3 would be equal to 3 because, the 60-degree side, they tell us it is equal to 3, literally. So in order to find X, we have to take the side length for the 60-degree side that they gave us, and we have to divide that by root 3. So we do X is equal to 3 over root 3, which is equal to root 3. So that means, well, X is equal to root 3. Now the last triangle, a 45, 45, 90 triangle, as usual, we have to find the measurement of side A. So we simply take root A, multiply it by root 2. It's going to be equal to root 16, which is equal to 4. So A is equal to 4. Are there any questions? All right, let's move on. This question is very, very complicated. So I want you guys to, in a similar manner, do what we did in the previous question, or not the previous question, but a few questions back, where I asked you guys to find as much information as possible. Okay, try and find the side lengths of BC, try and find the side lengths of BA, and something like that. Okay, I will give you guys a couple of important formulas. The area of a circle is equal to pi r squared. Okay, and then they say OB is equal to AC, which is equal to 6. So AC is equal to 6. OB is equal to 6. Both of those are very important pieces of information. All right, then. I'm going to give you guys 3 minutes to think on this starting now. Try and find as much information as possible. Try and find OA or, BC, and try and find all those. All right, then, everybody. A little bit of time has passed. Let's come back and check out this question. Okay, so they ask us to find the area of the shaded region. That is a little bit tough because we are lacking a lot of information. In order to find the area of the shaded region, we have to do triangle minus the circular segment. So basically, we have to find the area of this entire triangle, and then we have to find the area of this segment over here and subtract it from the area of the triangle. But how do we figure out what the area of the triangle is? Well, I'll tell you. It's actually a lot simpler than you think. Okay, well, not simple, but you need to have a sharp eye and realize certain things. So AC is equal to 6 and OB is equal to 6. If you notice something, they say O is the center of the circle. So any point that starts from the O, the center, and goes out to the edge of the circle is considered a radius, right? That is the radius of the circle. Couldn't you say that OA over here is also equal to 6? You know, the line starts from O and it goes to the edge of the circle, which is point A. So OA is also equal to 6. You know what that means? OC is equal to 12. Now, do you guys notice a pattern here? I think this is a unique triangle. Oh yeah, also just to mention, it says segment BC is tangent to the circle at B. It's kind of a it's kind of like a niche bit of knowledge, but if you have a point on a circle and there's a line that is tangent to it, and you draw a line straight from that point all the way down there, you create a perpendicular angle. Okay, so angle OBC is perpendicular. But even if you didn't know that, you could kind of assume that this is a right triangle because you found a side length of 12 and you found a side length of 6. And that tells me this is probably a 30, 60, 90 triangle, which has a ratio of 1, root 3, and 2. In this case, this 6 over here corresponds to the 1, and then this 12 over here corresponds to the 2. So if the 30-degree side is equal to 1, that means BC has to be equal to 6 root 3, 6 times root 3. So now that, yeah, we found the length of the height and the length of the triangle, the area of a triangle is equal to half times base times height. So half times 6 root 3 times 6 is equal to 18 root 3. So that is the area of the triangle, okay? Now we have to find the area of this segment of circle, okay? So let's just erase everything over here. How do we find the area? Okay, well, we know for starters, we can find the area of the entire circle because area of a circle is equal to pi r squared. And what is the radius? The radius is 6. So area is equal to 36 pi. Now, do you remember how we figured out this is a 30, 60, 90 triangle where this is the 60 and that is the 30? So in an entire circle, that full range of motion is 360 degrees, right? So think about it like this. If we had a full circle and we had a piece of that circle that only went 60 degrees, 60 degrees, what is 60 divided by 360 or 60 of 360? That is equal to 1/6. So a 60-degree angle segment of a circle is equal to 1/6 of a circle, right? So we could say that this segment, this segment over here of BOA or BOA in this case is equal to the area of the circle times 1/6 because the circle represents 360 degrees, right? And we know that the angle of the circular segment is 60 degrees. So that means that the area of that piece of circle is equal to 1/6 of the entire circle. Someone in the chat asked if we are finding the arc of a circle. Yes, that is basically what we're doing. We are finding the arc of the circle. So in this case, what is the area of the circle? 36 pi. So 36 pi times 1/6 is equal to 6 pi. So if we clear everything out, and we know that the area of the triangle is equal to 18√3, and that this arc of boa is equal to 6 pi, then we have to do the area of the triangle minus the arc, right? So that's going to be 18√3 minus 6 pi, and therefore B is the correct answer. That was a very, very large question. I'm not going to lie. Someone asked if I could replace the work after I put the answer. So I put all the work back up there. But yeah, Sarita, you have a question?
Yeah. So when you did the area of like the entire triangle, like
Yes.
including the arc, you said half time, like 1/2 times 6√3 times 6. So is that like, why did you also multiply 6? Because I thought it was half BH and the base
Half BH. So the base
is 12, right?
is equal to 6√3 over here, and then the height
Oh.
is equal to 6. So half times 6 times 6√3 is equal to 18√3. Is that clear?
Yeah, I put my base as 12. So why did I
Oh,
get
no. Your base is not 12. You see, when you're drawing a triangle, this is your base and this is your height. These are what we
Yeah.
call adjacent sides. You see, the side you put, this side
that-
over
yeah.
here, this is the hypotenuse. This is the like sort of side that corresponds to the 90-degree
Oh.
angle. We never ever use that as our base.
Okay, yeah. I
Yeah,
see
you
what I did
understand
now.
now?
My bad. Yeah,
All right,
thank
no
you.
worries, don't worry. That was a good catch, though. I can imagine there are many other students who might have gotten confused that way, so good thing you caught on to that. Sitara, you have a question?
Yeah, so my question is for B, right?
Yeah.
Since it's part of the circle and the excess shaded area,
Yeah.
if we see something like that, can we automatically think that it's a 90-degree angle?
You can think it's a 90-degree angle if they specifically say that the line is tangent to the circle. If they say the
Okay.
line is tangent to the circle, you can assume it's a 90-degree angle.
But if it doesn't say that, then you can't assume it.
Yeah, you're not safe enough to assume that, yes.
Okay, thank you.
Thank you, that was a good question. And Radula, you have a question? This will be the final question.
Yeah, I have like two questions though.
Sure, it's okay.
The first one is, how do you figure out if it's like hypotenuse or if it's a base?
Okay, easy. If you have a triangle with a 90-degree angle, the hypotenuse is opposite to the 90-degree angle. So if you see a side of a triangle and the 90-degree angle is opposite to it, that means it's the hypotenuse. If the 90-degree angle is not opposite to it, that means it can be a base or a height. Does that make sense?
Yeah, thank you. And also,
Mhm.
why'd you multiply it by like the arc of the circle, like the area and then multiply it by the arc?
Yes, we did. We took the area of the entire circle and we multiplied it by 1/6 because we know that the degree measure of the arc over here is 60 degrees because we figured that out from knowing that the triangle is a 30, 60, 90 triangle. So 60 degrees is 1/6 of 360 degrees, right? Imagine the full circle is going 360 degrees. So if we took only 60 degrees of that 360-degree circle, 60 divided by 360 is 1/6, right? So if you took a 60-degree segment, that would mean you're taking a 1/6 segment of that entire circle. That is why we multiplied it by 1/6. Does that make sense?
Yep.
All right, thank you. All right, no worries. So yeah, B is the correct answer. I appreciate you all for following through that with me. Let's move on to the next question. Okay, this question, trapezoids and parallelograms, we are going to come back to this later because in recent memory, this has not been terribly applicable in the SAT, so we will come back to that later when we have time. But for now, we will do a mini quiz. I'm going to give you guys 5 minutes to do this starting now. You can use a calculator on these questions if you like. All right, everybody. 5 minutes are up, maybe a little bit more than 5 minutes, but yeah, more than 5 minutes are up. Hopefully that was a good break for some of you. Let's get to solving these questions. Okay. So the first question is actually really easy. We have a hexagon with 6 equilateral triangles. Find the measure of angle x. You don't actually have to use the method I said from before. Equilateral means a triangle that has equal sides. So any triangle that has all equal sides, like 3, 3, 3, for example. What that means is all the angles are congruent to each other. So if we have 180 degrees total in a triangle and all the angles are equal to each other, that means every angle is equal to 60 degrees. So x is equal to 60. Of course, you could also use the isosceles method where you imagine the center is equal to 360 degrees, and which means that each segment is equal to 60 degrees. So then you're left with 120 and you divide that by 2, which is equal to 60, but this is easier. Okay, in the next question. In the figure above, point B lies on AD. What is the value of 3x? Okay, we see here that there is a perpendicular angle of ACB, which means that the angle CBD is also perpendicular, supplementary angles. So we have to find the value of 3x. So in order to find 3x, we need to find x, right? So all we have to do is take x, 2x, and 2x and add them all up together, which gives us 5x. 5x is equal to 90 degrees because all those angles added up together correspond to a 90-degree angle. We have a right angle down here. So that means x is equal to 18. Okay. So then 3 times 18 would be equal to 54. C is the correct answer. Now the next question, we have to use some angle rules, okay? They say, okay, we have to find the value of y. We have to find this angle over here. They say x is equal to 100. So this is equal to 100. Now remember, 180 degrees is the total angle measure in a triangle. So 180 is equal to 20 plus 100 plus angle ACB, this angle over here. So angle ACB is therefore equal to 60 degrees. And remember the postulate of opposite angles or vertical angles, they are congruent to each other. So that means this angle over here is also equal to 60 degrees. And then this angle over here is equal to 40 degrees. So we use the same 180-degree total rule. 180 degrees is equal to 60 plus 40 plus angle, we'll just say angle y in this case, since that's easier. Angle y, therefore, is equal to 80 degrees. So C, once again, is the correct answer. Are there any questions on these two problems? Nope. Okay, let's move on. They're asking us now to find the measure of angle B over here. So how do we find that? Okay, well, we know that this angle over here is equal to 90 degrees because they say lines AD and BC are parallel to each other. So if angle BCD is perpendicular or a 90-degree angle, then that means angle ACD also has to be a perpendicular right angle. Now, you see, we could say that the total angle measure in a four-sided shape is equal to 360 degrees, but we don't know what the angle measure of angle A is either. So that puts us in a little bit of trouble, right? Now, they give us some important information. CD is equal to half of AB. So whatever CD is equal to, let's say, whatever AB is equal to, let's say A, C would be equal to half of that, half A. So how can we use that? Well, here's what we can do. What we can do is, this is going to take a little bit of liberties, but okay, basically there's a tactic you can use where you can create multiple shapes within a parallelogram. So let's say we started from point B and we created a perpendicular line all the way down to the bottom, okay? A line that's perpendicular to AD that starts from point B, okay? Now, if we have two perpendicular lines that are perpendicular to line BC and AD, that means that these two lines, let's say this is point E over here, we're creating something new. Let's say that lines BE is parallel to line CD. So these two lines are parallel and they are the same height as well. So they are the same length as each other. So that means if line CD is equal to half A, line BE is also equal to half A. And what you should recognize here is that this is a special triangle because we have the hypotenuse being double the value of an adjacent side. 2, 1, root 3. You see what I'm saying here? So in this case, if we have a special triangle, then we can take a look at this specific angle segment over here. By the way, we already know that this angle over here is equal to 90 degrees because we explicitly stated when we created it that it was going to be perpendicular. So that's 90 degrees. We know that the angle measure is greater than 90 degrees, so we can immediately eliminate D from that equation. And then if we know that, triangle ABE is a special triangle, a 30, 60, 90 triangle, we can say that angle B is actually 60 degrees. Why are we saying it's 60 degrees? Because 60 corresponds to the root 3 side. It is the second largest. Angle A is the smallest and it corresponds to the 1 side. So we can do 90 plus 60 and we get a value of 150. Before I move on, are there any questions about the question we were just on? Satara, you have a question?
Yeah, hi. So I just solved the problem by like breaking down like a triangle, like a right triangle, and just doing the 60 plus 90 when I got 150. But I never incorporated the 1/2. So I kind of got like a little confused when you did the 1/2.
Oh, okay. Well, it doesn't matter what method you take as long as you get the right answer. I assume you probably created a different type of angle than I did, or you created a different line. Maybe you created 2 triangles, am I correct?
No, I just did the triangle that you did, but I just like automatically assumed that was like the 30, 60, 90 because of the right angle.
Oh, okay. Well,
Yeah.
in my opinion, you are a little bit lucky in this case because you happened to assume it was correctly a 30, 60, 90 triangle. But I mean, tell me, what happens if maybe it's not a 30, 60, 90 triangle? What if maybe it is a 45, 45, 90 triangle and you incorrectly assume the wrong type of special triangle? That is why we have to be very, very careful and we have to use logical information. We have to say if line CD is half of AB, that means that this line over here, BE, is also half. And we know that this, if you ever see 2 sides of a triangle where the hypotenuse is double the length of one of the adjacent sides, that means it's a 30, 60, 90 triangle. You should come to a logical conclusion like that. So I understand your confusion, but it's like I said, it's a little bit dangerous to assume things like that, right?
Okay. Yep, makes sense. Thank you.
All right, no worries. That was a good catch. Okay, and then the last question. Oh boy. This one is definitely a complicated one. Okay, we're gonna have to do some more radius stuff, okay? In the xy plane, the circle has a center hk and a radius of 10. What is the value of k? So basically they're asking us, what is the y value, or what is the height from the bottom of the x-axis, okay? They said that the radius is 10, so that means from the center to any point on the edge, that is going to be 10, right? So that means if we made a line from 4, 0 to hk, that would be 10, right? So to find the value of k, well, see here, in this circle, we have this line over here, right? Right in between 4, 0 and 20, 0. So that's the length of that line is going to be 16. So hk is directly in between these 2 points, okay? So we can say that the length of this segment over here is 8, right? So if we kind of use the Pythagorean theorem, we assume that that is a 90-degree angle, a perpendicular line. If we use the Pythagorean theorem, we can do 10 squared is equal to 8 squared plus a squared. Wait, sorry. A squared, then we get 36 is equal to a squared, and then a is therefore equal to 6. So in this case, the side length of this triangle over here would be 6, and just like that, we found the y value of this point. So k is equal to 6. All right, let's move on. Oh, okay. Seems we got a decent amount of questions. We'll only be able to take a few questions. Rachana, you have a question?
Yeah, so where did you get the 16 from?
The 16, I got the 16 because we have 2 points, 4, 0 and 20, 0. So these 2 points right over here, the length of the x-axis in between 4 and 20 would be 16, right? 20 minus 4. That is where I got the 16 from.
Oh, all right, thank you.
No worries. Katya, you have a question?
Does the K mean the height?
Yes, the height of the triangle.
So what does the H mean?
H simply means the x value. The H is not important at all. We're only talking about the K value.
Okay, cool, thank you.
No worries. Yeah, be careful of getting hung up on unnecessary information. The SAT likes to do that a lot. Okay, a complex volume question. All right. So basically, this is the type of question where you have to find 2 different types of volumes based on the information they give you, and you have to be like sort of aware of a lot of changes going on. Okay, so in this question, we have a glass sculpture in the shape of a prism, okay? The base of the outer shape is a square of side lengths of 2 inches, okay? So they say that the base of this sculpture is a square, so 2 inches 2 inches long, 2 inches wide, okay? The height is 5 inches. Now, the sculpture has a hollow core that is in the shape of a similar prism. The glass in the sculpture is a 1/4 of an inch thick, 1/4 of an inch thick on all sides, okay? What is the volume of all the glass in the sculpture? Okay, so basically what we need to do is we need to find the volume of the entire prism. We have to find the volume of the outer prism, and then we have to find the volume of the inner part. So then we take the full volume, subtract it from the inner hollowed portion. We subtract the inner hollowed portion from it, and we will get the total amount of glass left in the prism. So in order to find the full volume, that's pretty simple. We just do 2 times 2 times 5, and that gives us a value of 20. Okay, now for the volume of the inner, okay, so we have length times width times height, okay? So how does the length and the width change? Now you might say, okay, uh if the thickness of the glass is 1/4 of an inch, then we have to subtract 1/4 of an inch, right? Well, you're on the right track, but you have to subtract 1/4 of an inch twice, actually, because we have 1/4 of an inch on the right side, and we have 1/4 of an inch on the left side. So it is being shortened from both sides, okay? So in this case, the width of the inner portion would be equal to 1.5. And in the same way, the length would also be equal to 1.5. Now, keep in mind, they say that the height of both the glass and the hollow core is 5 inches. So height is still equal to 5, okay? So what is our new volume of, like volume inner? That's going to be 1.5 times 1.5 times 5. So 1.5 times 1.5 is equal to 2.25. And then we multiply that by 5. That should give us a value of 11.25, I believe. And then we subtract those two values from each other and we get 8.75. That is the amount of cubic inches of glass in the sculpture. So B is the correct answer. Do we have any? Okay. Mohit, do you have a question?
How did you get 1.5 as the width and length for the second volume?
We got 1.5 as the length and the width because they say that the thickness of the glass is 1/4 of an inch thick. So if we were finding the inner portion right over here, then we have to take 2 inches, which is the length and the width, and they say that the thickness is 1/4 of an inch. So we're going 1/4 of an inch inward on the left side and the right side. So we're shortening from both sides by 1/4 of an inch. So 2/4 of an inch is a 1/2 inch, 0.5. So 2 minus 0.5 is going to be a shorter length of 1.5. And then we do that for the length and the width, since it's shortening from the left, right, and the top and the bottom.
Okay, thank you.
No worries. Do we have any other questions? Okay, let's move on. Circular equations. Okay, we're gonna go a little bit quickly with this one. Okay, so newsflash, equations can also be used to generate circles, and they can be really, really big. The general equation for a circle is what you see right here. X minus h squared plus y minus k squared is equal to r squared, where h is equal to the x coordinate of the origin, k is equal to the y coordinate of the origin, and then the r is equal to the radius of the circle, okay? So you see this equation down here at the bottom? That equation actually generated the circle that you see to the right, okay? So how do you actually draw a circle like this? Just by looking at the equation. So for starters, I look at this 3 over here, and I immediately think, okay, so that is a -3. That means that the x coordinate has to be 3. And then I see the +2 over here. So you know how y minus k is the default state? So if we have y +2, that means that this is what basically happened. Y minus -2 squared. That means that turns into a y +2 squared. That means that the y coordinate is equal to -2. So if you see a plus, that means it's negative. If you see a minus, that means it's positive. So 3 comma -2. That is our origin. So if we go over here, 3 comma -2, notice that is exactly in the center of the circle. We just created the origin of the circle. Now the radius is equal to r squared. So for some reason, don't ask me why, when you're making a circular equation and you're saying all this gibberish, x plus y, all that stuff is equal to something, that something needs to be r squared. It cannot be r, it has to be r squared. So in this case, r squared is equal to 16. So that means that the radius is equal to 4. So let's double check that. If we start from -2 over here and we go 1, 2, 3, 4, well, that is a radius length of 4. And we just generated, and that, that is consistent with what the circle shows over here. So hopefully this was fast but clear enough for you guys to understand how circular equations work. So here is some practice. We don't have much time. I'm going to give you guys 2 minutes. Okay, now 2 minutes should be enough. 2 minutes to solve these problems starting now. In the meantime, I didn't make it very clear. I forgot to change the font color over here. I want you guys to write the function of the circle drawn above based on the structure I just gave you. All right, then, everybody, 2 minutes are up. So let's quickly get these questions out of the way, okay? So state the vertex and radius of the circle created by the first function, okay? So since this is x plus 49, the origin is going to be -49 for the x variable, and then we have a minus 28, so it's going to be 28. And then r squared is equal to 81, so the radius is equal to 9. Now, the next one, vertex, is going to be 13 comma -3, and then the radius is going to be 49 is equal to r squared, so r is equal to 7. All right, so write down the function of the circle drawn above. Okay, so we can clearly see if we go from top to bottom, there are 4 square lengths, so the center is going to be right over here. So how many, okay, so the origin is basically 1 comma -2, right? So the x portion would be x minus 1 squared plus y plus 2 squared is equal to, what is the radius? So from -2 to -1, the radius is equal to 1, right? So what is 1 squared? It's just 1, right? So r squared is going to be equal to 1. This is the equation that corresponds to the circle above. The next circle, the origin is right over here, and then the radius is from 5 to 7, so radius is equal to 2. And then the origin is what? 0 comma 5. So here's the thing. If your origin is ever on the x-axis or y-axis, then you just eliminate the constant from the equation. So in this case, we don't have to do x minus anything. It's literally just x squared. Because, I mean, what else are we going to write? X minus 0 squared? You can just simplify that to x squared. And then plus y minus 5 squared to represent the y value of 5. And that is going to be equal to r squared. R is equal to 2. So that r squared is going to be equal to 4. That is the equation of the above circle. And would you look at the time? It is 9:01. So we are going to stop here for today, and we're going to pick up on class on Thursday as usual. If you have any questions, you can just stay back and I will answer them. But for now, I will let you all go. Have a good day. Rahul Kanaparthi asked in the chat, is next class math or English? Next class, we're going to finish math and we are going to get started on English. Vindhya 3, you have a question?
Could you use SOHCAHTOA for special triangles?
Yeah, you could use SOHCAHTOA for special triangles, but in my opinion, that's a bit too much effort.
Oh, okay. Because I was taught that way.
Oh, yeah, no worries. I mean, if that works better for you, then you can absolutely use it.
Thank you.
No worries. All right, since there are no other questions, so we're going to head out now. Have a good day.